Hi, this is Miss Cole again, and today we're going to be talking about our third lesson in our unit. We're going to be talking about slopes. Now, yesterday we talked about rates of change, and slope is really just a fancy rate of change on a graph. So if we have the same graph, there's slopes between each of these points, and we can calculate them, and it would be the same thing as calculating the rate of change. We're just going to take the change in y and divide it by the change in x. Change in y divided by change in x. And this little triangle symbol, this is actually the Greek symbol delta, and it just means change in something. So whenever you see this triangle, you can think in your head, change in. It's actually very commonly used in math and science. So let's look at some real-world examples of where you might actually see slopes, where they might be calculated, where you might actually need them. Okay, the first one is on your house. If you work in construction, you want to know the slope of the roof. And actually, it was a construction guy who first taught me about slope, and he called it rise over run, which was the easiest way for me to remember it. So in roofing, we want to know how steep is this roof. We need to take the change in y, then we take the change in x, and we divide them, and it's called rise over run, because remember, the y goes up, and the x goes across. It's rise over run. The other thing I want to point out to you here is that my distance is measured from the top of this line to the bottom of the line, but in a nice straight line up and down. And once again, it's measured over from the start on the right and the start on the left. A lot of people are going to want to go all the way over here, but that's not right, because I didn't measure how far it changes going up that way. So I just want to make a nice right triangle. Another example is going to be if you are on a road, especially in the mountains, you need to know how steep the road is. So how steep is that road? If you are driving a big truck and it's heavy, you want to make sure you know if the road gets too steep and you need to change to a lower gear, or otherwise be safe. So in this case, we're going to be measuring how steep this line is, and we're going to measure how much it goes up and compare it to how much it goes over. So I'm going to have a change in y and a change in x. A lot of times they call this a grade. So now we got to imagine a grid being put over those pictures. So if we have this coordinate grid, we can very easily measure how much up and how much over by looking at the coordinates. So we have the coordinate here, marked with a little dot, at 2, 4. So you notice it goes over 2 and up 4. And then we have another little dot down here, in which we go left 1 and down 5. Left is negative in this case. Yesterday somebody posted that they have troubles remembering which comes first, the over or the up, the x or the y. And the way you can remember this is, imagine yourself with a little ladder right here. You can't climb the ladder and then move it. First you have to move the ladder and then climb it. Sometimes that just helps to remember. Okay, anyways, so we're going to calculate the slope of this line between negative 1, 5 and 2, 4. So what do? Well, we need the change in y. So we look at the second coordinates, 4 and negative 5. 4 minus negative 5, and we get 9. And now we're going to look at the x-coordinate, which is the first one, and we need to go 2 minus negative 1, and we get 3. Now we're going to compare them, which means divide them, and delta y over delta x, and we get 9 over 3. Now we're not done yet, because you can't forget to simplify. Oh, simplify, it'll be 3. Okay, so if you want, you can write this in a more complicated way. You can write it with this nice big equation. And some people get confused with this equation because it's like, what's these little 1s and these little 2s and all this craziness? All it means is that you have to make sure that you pair this up. So this x and this y are from the same point, and this x and this y are from the same point. You don't want to mix them up, because then you wouldn't get the right answer. Then this one would be negative. Negative 1 minus 2 is negative 3, and then my answer would be negative, and that's just not right, because this is obviously a positive slope. I also like, sometimes, to make sure I don't mess up, I like to take the points and stack them. So if I take 2, 4 and I stack it over negative 1, negative 5, it's it's very easy to subtract them, and then I won't be mixing the coordinates up. I go 4 minus negative 5, and I get 9, 2 minus negative 1, and I get 3. The only trick here is that you have to remember to stack it y over x, so the second one goes on in the numerator on the top. So wait, there it is, there it is, there it is! There's our simplified answer. This is our difference in y, this is our difference in x, that's why I circled them. Alright, we can also do this from a table. Now if you look at this table, it'll either be labeled with two different coordinates. And in this case, we have a nice straight line, so they go up at a constant rate. So I can pick any 2 points and calculate the difference between them. But what's a point in this? A point is an x and a y that go together. So this is a point, and 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 so on. So I'm going to calculate the slope between the first 2 points. First I'm going to calculate the x, which is fine. So I go negative 1 minus negative 5, right here, right next to each other, and I get 4. That's the difference between my two x values. For my y, I'm going to take 0 minus negative 2. Forgot my negative. So 0 minus negative 2, and I get 2. And then, so my final comparison, y over x, is just 2 to 4. 2 over 4, which simplifies to 1/2. Alright, and those are some of the references I used. These two graphing places, this one you would put in the points, and you would actually put them in as a table, and then you'd get the graph. This one is just fun, because you just get to put in whatever you want, and it tells you what the graph would look like. Alright, see you later.